So like I said, you can see I've got a circuit set up here. I'm going to run you through what I've got going real quick. Because it's a wood back right here, it's not going to conduct a normal ground like we've been talking about, all the building steel and the ceiling grid and the electrical pipes and water pipes. Those are all conductive of ground. And conduit is as well. We don't have that set up on a wood back like this. So I used this green wire you can see over here, and you can kind of see it between the devices. I had to connect each box that these are mounted to so that I could create a ground. Because what I've done with my 6 devices here is I've made a small little NAC circuit of just strobes and horn strobes. And I created a few problems like what we've been talking about. In one of the devices, we're going to find an open circuit. Another device, we're going to find a reverse polarity, like it was wired backwards. And in a third problem, we're going to find one of the devices has a ground fault in it. And the point of what we're doing today is we're going to learn how to find all those using our meters, not our panels. So I had to create this ground circuit to connect from box to box so that I could do things like have a ground fault. I'll show you real quick. If I have my meter set on the ohm setting, this is that Greek omega letter. I'm going to take, hold on, my meter leads are a little twisted here. I'm going to take one of my meter leads and I'll touch this first box. I know you can't really see it because the device is in the way, but I just took the end of the meter lead and it's touching the box. I'm going to go all the way to the other end and I'm touching the other box, and my meter reads 0.1 ohms because there's a solid connection via that green wire going from box to box to box. And I can do that with any boxes, any combination, 0.2, 0.2 ohms right here. Also 0.2 ohms, 0.1 ohms. So all of them are connected, and that's simulating our earth ground for today. The other thing I have going on is this 2-conductor red wire. I found out after I started using it, this is actually a shielded wire. I should have paid more attention to the label on the spool, but I was using just a kind of a junk spool that had almost no wire left on it because I didn't want to waste a good spool on something like this. So it having a shielding is fine. I just cut it back and stuck it like this. But if you're on a job and you're pulling big, long circuits, shielded wire costs more. So if you're not doing something with speaker circuits or something that specifically calls for a shielded wire, don't use it like I did. And then other than that, it's going to go from device, my red wire comes in one side, it jumps from this device to here all the way down. And that last one over there is that's where my end of line resistor is. So this little coil of wire is my home run right here. All right, so let's say you've got your NAC circuit trimmed out, and in this case we've got 6 devices, maybe you've got 15 or 18 devices. All the things that we work with and talk about today, they'll all work no matter what size the circuit is. It's just, it was hard, excuse me, it was hard enough getting 6 devices in this camera shot where you can still read the meter, let alone trying to fit like 18 devices on this board where you can see the meter. So trying to keep it at a practical level here. But everything we talk about, these are all going to be methods you can use to troubleshoot. So the first thing we want to do, say we have our circuit completely trimmed out, completely built, ready to land on a panel, and we have our home run here, and we're ready to land this home run to its terminals. Before we ever do that, we want to take our meter leads and we want to have it on that omega ohm setting because we want to check for resistance. We need to look and make sure our whole circuit's there. This can help us not only if we're trying to connect it to our panel, but maybe your panel's on back order, maybe the electrician hasn't finished getting power to you or whatever, but you're at a point where you need to start making sure all your stuff that you've trimmed out is working well. So this is a way you can do that while you're waiting on other things to happen. So we're going to take our wire and we're just going to connect our red conductor to our red meter lead and our black conductor to our black meter lead. Now, I don't know how well you can see this in the camera. I'm making sure that I don't touch any of the copper or the meter leads with my hands. We talked about that in one of our lessons before where we went over using a meter. If I let my hands touch the copper and my hands touch the meter leads, it can actually create a connection through my body and I'm not reading the circuit properly. So right here, looking at these, I'm bouncing around between 1.2 and 1.3 mega ohms. That tells me I've got an open circuit somewhere. There's a Right here, there's an M beside the ohm symbol. I don't know if you can see that on your phones, but it's mega ohms here. And so when I'm in the mega ohm range, that's kind of the equivalent of an open circuit. So whenever we see that with our meter, the first thing that we need to do is we need to identify where the circuit's running in the field. In this case, it's very simple. We've only got one circuit and it's all right in front of our faces. But if you're on a job and you've got 4, 6, or 8 circuits running to the same room, you need to make sure you use labels. You can label it NAC 1, NAC 2, and when you're keeping your as-builts, this one's NAC 1, this one's NAC 2. And so when it comes time for this point, you can know where you're going through the building so that you can find where your devices are. And you're going to want to pick the center of the circuit. So I've got 6 devices here. I'm going to use device number 3 as my center, because then I can count home run as 1, then it's 1, 2, 3, 4, 5, 6, 7. So that kind of makes this the center. So I'm going to open this up. And real quick, I'll stop real quick and talk about the tools that you need for this kind of work. These are the bare minimum essential tools for doing fire alarm. Obviously, we need a meter. Talked about that several times already. We're going to need some kind of screwdriver. I personally like Klein multi-bit type of screwdrivers. It's really nice if anything ever happens to the tip or anything strips out or wears out, I can go to any Home Depot and they'll replace it for free. And Home Depots are everywhere. So I've been out of town working before, Odessa, Oklahoma, Corpus Christi, places that are away from home, away from my spare tools. And I've had something mess up with a tool and there's a Home Depot everywhere. So I could just go get it replaced. And it wasn't a big hassle. So I didn't loosen that all the way. Okay, there we go. All right, so I've gone to my center device and I've got my wires here. So what I'm going to do, I'm going to just take them off real quick so I can get to where I can work with them. Try not to knock this display board over on my head. All right, now what I want to look for is I want to look and see if I can see either back to my home run or if I can see all the way over to my end of line resistor. So to do that, I need something going on at my home run so I can identify it. So what I'm going to do right now is I'm just going to twist these together to create a short. So one direction, looking at these wires, which will be this wire because we can see it comes back this way, I should be able to see a short. If I can see a short, then that tells me everything from here to here is good. From here, I want to be able to see my end of line resistor. If I see my resistor, that tells me from here to here is good. So one of these sides of the circuit is going to have a problem. And that's what we're looking for right now, is which half of the circuit is our problem in. So I'm still on my resistance setting. I'm still making sure I don't touch the copper wires. And my meter says 0.4 ohms. So I see that short. So I know I'm good for my home run to this device. My first half of my circuit is good. Over here, I'm going to put that on there. And it's completely open. It says OL for open line. So I can't see my end of line resistor. That tells me I've got a problem in between here and here. So what I'm going to have to do is I'm going to have to repeat this step of where I went to the middle of the circuit to find the problem. I'm going to go to the center of the next section, which will be this device. Because see, I've got 1, 2, 3. This one's the middle of those. But before I do that, I'm going to put this one back together so I don't have to come back to it and do more work than necessary. So there we go. I got my 2 positives split. I made sure I put my 2 negatives under the same terminal. And they're all the way in. Tighten it down. I want to go just double check that all my screws are all the way tightened down. Now you don't have to be like the Incredible Hulk tightening them down, but you want to make sure none of your conductors can come out. Just doing simple checks like that, you can catch problems before you have to go around troubleshooting. And then I just reinstall the device. All right. Now I'm going to come over here. I'll try to stay out of the way. And we're going to, like I said, we're going to come to this because this one's the center of the second half of the circuit. I'm going to open this device up, and I've already found my open circuit right here. I can see where the copper was put under it, but maybe the wire was nicked when it was being landed. And then I can pull, the other ones seem to be doing just fine. So what I'm going to do, I'm going to go ahead and break it. I'm going to get rid of that conductor right there out of my way. Pull this over here. And I'm going to restrip this wire. By the way, I like these cutters a lot. They're also by Klein, so they get that same warranty. You have a real good cutter here instead of the crummy cutter that normally comes on strippers, but you still get the actual strippers. So they're real nice to have carrying around if I'm on like a service call and I don't want to have to carry a whole lot of tools and be weighed down by all that. Doing it this way, that one tool does a lot for me. And I'm not trying to tell you y'all have to go get Kleins, but just have good tools that you can do good work with, whatever your preference is. Just make sure you have tools. These ones I'm working with today are pretty much essential. You need a good screwdriver. You need a good set of cutters. Oh, I forgot to verify my repair for y'all real quick. I'm going to have to do some double work because I was talking and not thinking about what I was doing. All right, so I still, even though I found an open circuit, I want to verify right here at this device that I have fixed the problem, that there's not another problem on the circuit. So I'm going to put my meter on. I'm still on the resistance setting. I'm going to check right here. And I see that 0.2 ohms, that's the hard short. That goes back to my home run. And then here, I'm going to check. I see 4.577. That's going to be my end-of-line resistor because I have a 4.7K end-of-line. So that's what I want to see. I can see my resistor here, and I can see my home run on the other side of the circuit. So now I'm going to put this back together again, since I verified the repair. Verifying the repair is really important to do so that you don't end up just running back and forth like a chicken with your head cut off. All right, so I'm here, put all this in, I've pulled on it. So now I know all my conductors are in there solid. If you pull on it like that, it'll keep from having this type of open circuit that we just saw here, because having pulled on the wires, I'd know that that conductor was broken. So we've just fixed the open circuit condition that we had. So I'm gonna reinstall that. Okay, now let me come back over here. Chair out of the way. All right, so I'm back at my home run. And again, verifying the repair is important. So now I'm going to undo that short that I made. And I'm going to see, I can see that 4.2 K ohms of resistance touching it like that. Let me try to get you a better camera angle so you can see kind of how I'm holding it. I'm holding it so that I've got the meter lead pinched in between these fingers, the wire's there, and I can hold this without having to touch any of the copper. That's 4.2 K ohms, so I see that resistor. Now the other thing we want to do is we want to check for reverse polarity, because if you have reverse polarity on these circuits, it's going to come up as a short on your panel, even though it's not actually a short. And so the easiest way to check it is reverse the polarity of your meter. We've been doing red meter lead to red conductor and black meter lead to black conductor to get that 4.2 K ohms. So now we're going to reverse it. Come on, there we go. 4.5 K ohms. Okay, maybe I didn't put a reverse device in here like I thought I did, because that's what we want to see. We want to see that there is a difference. If I checked it in both excuse me, both ways, if I see that like 4.5 K ohms or 4.2 K ohms, when I check it both directions, that means that if it's the exact same reading, that means there's a reverse polarity device. Because you have that diode in there that reads different one way than it does the other. But whenever you have them all facing the same way, they're going to read differently. So don't have to chase a reverse polarity device. Threw myself off there. Thought I put one in. And that lets us skip to checking for the very last thing. Now we're going to look for a ground fault. So again, I've created my ground reference here. I can use any of these back boxes as a good ground reference. Some of the other stuff we talked about in last week's lesson is any kind of bare metal that's around the building, conduit, water pipes, things like that. They have great ground references. The metal casings on air handler units, if you're working in the ceiling and you have an air handler right above you, you can touch your meter lead to the bottom of that drip tray. That's all grounded. So those are places where you can find good ground references. I didn't have any of that building this board, so I had to create this ground. And so I have a little alligator clip set that I have. So it connected to ground, and I like to work with as many free hands as possible. So I can clip that to my negative meter lead, and my meter is now connected to ground. And by the way, just so y'all know, my meter is hanging by a magnet here. Most meters you can buy these days have an optional accessory for a magnet. I highly recommend it. Having free hands to work with is nice. So then I can take my positive meter lead and I can go and check. So I see 4.2 k ohms. Now I should see an open circuit if I didn't have any reference to ground. But that 4.2 k ohms, if y'all remember, that's the same thing we saw when we were checking for the end-of-line resistor. So it tells me that there's possibly a ground fault on the negative lead, and what's happening is it's going all the way down the red conductor, coming across the end-of-line resistor, and then coming back to wherever our ground fault is, and coming over to the earth ground that my black meter lead is connected to. So to verify that, I will touch it against that one, and I have 1.2 ohms. So that confirms what I was thinking, that there was a ground fault on the negative side of the circuit, and it was seeing it by going all the way through the circuit, which it's important to understand that the closer you are to a ground fault, the smaller the number you have, the less resistance you'll have. And so by connecting to the red conductor, the positive conductor of the circuit, it's further away than the negative conductor because it has to go all the way through the circuit to circle back to it. Whereas the ground fault is on the negative, so just by tracing the wire, I'm already a lot closer. And then on larger circuits like schools, as you're chasing it through the field, you can see that number get even smaller as you chase it. We might not see that here because, I mean, we're talking about maybe 6 inches of wire from here to here, another 6 from here to here. So we might not see that number shrink here today. But to chase it, we're going to chase it very similarly to how we just chased the open circuit. We're going to come right here, and we're going to go back to our center device. The thing is, I'm really failing at this right now. All right, open that back up. And so we know it's not on our positive side, it's on our negative side. So I'm only going to remove the negative wire. I don't need to chase the ground fault on the positive side because it's not there. So now also similarly, you're going to want to do something to help you identify your home run. So I'm going to short it again. One of the other things I like to do, if I don't short it, I will, excuse me, I'll get a different valued resistor. So this is a 4.7 k ohm circuit. I might have a 15 k ohm resistor on me. I typically keep some 33 k ohms in my bag because they're different than pretty much everything, so no matter what system I'm working on. Having a 33 k ohm is really handy for that. And so I can put that 33 k ohm on here, and I know that if I see 33 k ohms, that is my home run, and it's not some other short that's in the field. So I'm going to go ahead and take this jumper off of here, and I'm going to use the back box because I'm going to pretend I'm going through the field. I'm going out into the, now there's not a hole, I can just rest it in. So I'm touching it to the back box there. I'm going to use that as my ground reference. Now this wire I can see comes to the left. This one I can see comes to the right. But I'm also going to show you how to check that whenever you can't necessarily see it. So first I'm going to try to identify which half of my circuit my ground fault is on. Touching the one on the right. Completely open line, no connection at all to to the ground. Check the circuit on my left, and I see it's 0.3. So that number did go down 0.2 ohms, 0.1 ohms. I have a very, very solid connection to ground right here. Now, in this case, it's very easy to see that this wire goes this way and this wire goes that way. But if you've got your wires zip tied up real nice, they're going up into the ceiling, up to your bridle rings, you're going to have both of those side by side, and it can be hard to tell which one goes which way. So since I know it's on this one, I'm going to put my black meter lead here and my red meter lead here, just like I'm checking for resistance. And I see a hard short, which tells me it's on the side that my home runs on. So it's going to be one of these two devices. And to verify that, I can put across these, and I see my end-of-line resistor. I've got 4.46 k ohms. So that's from here that way has no ground fault. So I'm going to go ahead and put this device back together because I know my ground fault's not here. My ground fault is somewhere over here. Draw my screen. And I just bumped the camera. Mike just wanted to say hi. That's what that was about. All right. So I'm going to go ahead and put this back together. Checked all my screws. They're all tight. Checked all my conductors. Nothing's breaking. Nothing's pulling out of the terminals. Put my device back on. All right, so that device is... Now, before I talked about splitting the circuit in half because we had 3 devices and, you know, that 3 might have actually been something like 8 or 9 in a larger circuit. In this case, I've only got 2 devices. There's not really a way to split that in half. It's a 50-50 shot. It's either here or it's here. If this was a larger circuit and say this was another 7 or 8 devices, then I would continue to split it in half and split it in half as necessary. But since it's just 2, I mean, I could flip a coin. I'm going to go ahead and just go to this next device here, device number 2, because when I checked it at my home run, I had greater resistance than when I checked it here. So it's most likely going to be closer to this device than it was to over here. But remember, it's always closer to where you have the least amount of resistance. All right, looking in here, I can already see that someone did a terrible job wiring this up because there is just way too much extra wire in there. It needs to be like this where you have just a little bit of wire, enough to work with, some slack in here, but you don't need all of this stripped back like this. And when I pull on it, this black conductor won't come over. It seems like it's pinched. So there's a good chance that's my ground fault. So I'm going to go ahead and loosen up my base. Really in there. Oh, that was definitely my ground fault. See, I got some bare copper here. It was pinched. And there's, you can see how much extra wire was stripped. We don't need to be installing devices with this much extra wire stripped in there because it's just asking for ground faults. So, Mike, you should fire whoever trimmed this device. All right, so I'm going to take that, and I'm going to go ahead and disconnect it so we can do like we did, checking for ground fault at the last one. Even though I know I did just find a ground fault, there might be more than one. So doing the same thing, I'm going to put my meter lead onto the ground reference, which in this case is our back boxes. Touch it right here. Completely open line. Here, completely open line. This one, open line. Right here, open line. So that tells me this was probably our only ground fault. And what I need to do now is I need to clean it up because this is terribly trimmed out. So I'm going to cut it off, cut off some unnecessary extra wire here, and take my strippers and just restrip it. And that's a little bit long. I don't want to cause any kind of shorts or other ground faults by not having that done right. And Put all my wires back in my base. All right, so I've checked they're all tight. I've pulled on them, checked all my conductors that they're not going to break off, come loose, cause an open circuit, because I've already tried to chase out that problem. I want to have to do it again. And then, so there we go. We're all put back together. Now, once more, we're going to go and verify all of our repairs, because now our circuit should be completely open and clear. And by that, I mean we should see the end-of-line resistor, no ground faults. All right, so I've got black meter lead to black conductor, red meter lead to red conductor. I see my 4.2 k ohms. I'm going to I'm sorry, Mike, I can't read.
Ground to a building, not the box. Ground. Talk about grounding to the building, something on the wire, where it's not in it.
Oh, some other things that can happen that can cause a ground fault like this. So this example, the wire was pinched in the device because I had too much wire in there and it got kind of shoved in there when I closed the device. Something else that can happen, we can have zip ties that are too tight. We can have sheetrock that comes in and pinches the wire up against metal studs or against red iron. There can be other things that pinch the wire to an earth ground reference. That's pretty much every time a ground fault happens, some way or another, the wire is getting pinched to another part of the building. So to just finish checking, I showed you we checked, we still have our end-of-line resistor, so we didn't cause any other open circuits doing our troubleshooting. I've connected this back to my earth ground little alligator clip. And I check it here, open line at my home run to earth ground on both conductors. Completely open line, no ground reference at all, completely clean wire. We have end-of-line resistance, no reverse polarity devices, no ground reference. This wire is ready to land on a panel. And whenever it lands, it'll come up as a clear circuit, no troubles on it. Look at that, it's right at 12:30. Yeah, if y'all have any questions, you want me to explain what I did, why I did something, I'd be very happy to take questions, answer anything else. Other than that, that's all I got.
I just want to make sure everybody's